Students, in this video we are going to discuss about the conservation of energy of a spring. Now imagine you have a spring and you stretch the spring, okay? You're stretching it by applying a force, which means the work is done and the energy is stored as potential energy. So you stretch it to maximum and you're holding it. So at that point, the spring is having maximum potential energy, but kinetic energy is equal to 0. Why? Because the spring is at rest. Now if release the spring, what happens? It will try to move back to its initial position. So its kinetic energy will start to increase, whereas the potential energy will start to decrease. Now at the so this is the initial position and stretch the maximum distance, say 2 centimeter. Okay, and I'm releasing it. So what happens? The spring will try to come back to its initial point. At that time, kinetic energy keeps on increasing, potential energy keeps on decreasing, reaches the initial point. At that point, maximum kinetic energy will be attained, whereas potential energy will be equal to 0. But the spring won't stop there at the instant. What will happen? It will go to the opposite side, and as it is going to the opposite side from the initial position 0, what happens? Its kinetic energy will start to decrease and potential energy will start to increase. Okay, so here we are going to, since spring force is conserved, sorry, I told you since spring force is conservative, the energy will be, total energy will be conserved. And we are going to take three conditions, 3 points in which the spring is traveling, and we are going to find out the total energy. So first, we are going to take the case of extreme position. Extreme position. That is x is equal to plus or minus xm. I told you about 2 centimeter. That 2 centimeter is xm here, and x is any position in between those two. Okay, so x is equal to x plus or minus xm. So at the extreme point, what happens? It is having the maximum potential energy and kinetic energy is equal to 0. So kinetic energy at that point will be equal to half mv square is equal to 0. Whereas potential energy will be equal to half k, general expression is kx square. In our case, it is plus or minus xm, so it is equal to half k x m square. Therefore, total energy is equal to kinetic energy plus potential energy is equal to half k x m square. So whichever point you take, at that point the total energy of the spring will be equal to what? Will be equal to kxm square. Next, we are going to take the intermediate points, that is any point between x plus xm and minus xm, the intermediate points. That is x can have any value. If xm is plus 2 centimeter and minus 2 centimeter, then x will be equal to 1 centimeter, 1.5 centimeter, etc. Okay. So, we know total energy of the spring is always conserved, and total energy is given by half k x m square. Now, kinetic energy is given by the equation what? Kinetic energy is given by the equation is half m v square. So we want to find out what is the value of v or v square. For that, we are going to use the equation total energy is equal to kinetic energy plus potential energy, that is k plus u. Now potential energy at any point of the spring will be u is equal to half k x square. This is the general expression for potential energy. So substitute here, you will get half k xm square is equal to half m v square plus half k x square. One by 2 get cancelled. We will get k xm square is equal to mv square plus kx square. Next, what I am going to do is I am going to bring the k terms together. So I will get k into xm square minus x square is equal to mv square, or v square is equal to k by m into xm square minus xm square minus x. So I got the value of v square is equal to k by m xm into xm square minus x square. Or velocity v at any instant between the intermediate point is root of k by m into xm square minus x square. So on substituting the value of x at any point 1, 1.5 etc., we will get the velocity and we can find out the at the same instant you can find the kinetic energy, potential energy, and definitely you will be getting the value equal to half k x square itself, which means total energy at any point of the spring is the same. Now I am going to take the initial or original point, that is the equilibrium position. At equilibrium position. Now at the equilibrium position, we know the value of x is equal to 0. That is the origin. Therefore, potential energy will be equal to what? 0. Why? Because potential energy equation is half k x square. General equation is half k x square, and at position equilibrium position x is equal to 0. So half k x square is equal to 0. And kinetic energy, general equation is half m. Instead of v square, what must we write? Root of k by m into xm square minus x square. And in our case, x is equal to 0, so we get half m whole square because it is v square. Half m root of k by m into xm square. Why? Since x is equal to 0 at equilibrium position is equal to half m into k by m. Xm square gets cancelled. You will get this half k xm square itself, which means at the equilibrium position also the kinetic energy is half k xm square. Therefore, total energy is potential energy plus kinetic energy, which is equal to 0 plus half xm square, which is equal to half k xm square. Which means at any point you take, total energy of the spring is the same, which means we can say energy of the spring, mechanical energy of the spring is conserved. Next, we are going to draw a graph relating energy and the displacement. Okay, graph between energy and distance of a spring. Okay, now this is x, this is the axis representing energy. Let this be the maximum distance xm. Now we know that for a spring, it is having maximum potential energy at the extreme points and zero potential energy at the equilibrium position. So this is the equilibrium position 0. Let this be the maximum energy representing point. Okay. So at the extreme position, potential energy is maximum, whereas at the equilibrium position or the origin, potential energy is minimum. If you draw a graph, you will get shape like this. Why? Because you know equation for potential energy is U is equal to half k x square. So which means U is proportional to x square, and for this U proportional to x square or y proportional to x square, the shape of the graph will be parabolic. If y is equal to x, the shape of the graph will be a straight line. If the equation is relating y is equal to x square, the shape of the graph will be parabolic. In our case, potential energy is proportional to x square, so shape of the graph will be a parabolic. Okay. Next, kinetic energy. Now, So this is the graph relating potential energy. Next we are going to draw the graph of kinetic energy. Now kinetic energy is having minimum value where? At the extreme points, isn't it? So minimum value at the extreme points and maximum value at the equilibrium position. Again, kinetic energy equation was also half k xm squares, and we got it. So shape of the graph will be parabolic. If you join the points, you will get the shape like this. This is the graph for kinetic energy. This is the graph of potential energy, and this much is the total energy equal to kinetic energy plus potential energy. I hope this graph is clear to you. This is a graph representing kinetic energy. This graph represents the graph of potential energy. Total energy will be the meeting point of these all, and is equal to kinetic energy plus potential energy. Thank you.